Exercise 510 revisits a concept that you were first introduced to in the preliminary course, and that's the concept of surveying. In that course, you just looked at one method of surveying called the offset survey method or traverse survey method. What you'll see now is that you're going to look at another two more. So plane table radial survey and the compass radial survey methods. So that's 3 in total. And the question often names the method, which makes it a little bit easier for you if you have made the connection between the name and how you approach or how you interpret that method. And so obviously I would encourage you to do that. So what is this offset or traverse survey? It's when the longest diagonal of a field is used as a traverse line, just means you cut across on the longest diagonal, and perpendicular distances to each corner are measured. So if you had a block of land doing something like this, you might take this as your longest diagonal. So you're going to start here and traverse across to there. And as you go, you measure off perpendicular distances. So you'd measure that distance and you'd move on a bit further and then you'd measure this distance. As long as we are perpendicular to our traverse line. So what happens then is that these perpendicular distances get entered into our field diagram. So you can see that we've, in this particular example, started at C, and how do I know that? It's because the first measurement here is a 0. Traversed or moved forward 25 metres, and there was a corner out on the right exactly at 90 degrees, and it was 22 metres out to the point B. So I'm going to draw the diagram so that we can get a sense of what's happening. So we know we're going here from C, we'll end up across at A, but to begin with, we head in, say 25 metres, and out directly to the right, another 22 metres is another corner. So this is the boundary. Now, in total, from C, by the time you get to here, you've travelled a total of 41. So if we went 25 to start with, 25 metres, then to get to 41, we've travelled another 16. So 16 more metres. So this little interval from here to here is 16. This time out to the left is another corner, and that's called D. And this is 26 metres. From 41 to 67 gets us all the way to A, and that's another 26 metres. This is also 26, and now we're at A. So our field actually looks like this. Now, from that, you can see that we could calculate the area, and really, in essence, we've got two triangles. I'll try to outline them. So we've got this triangle with its perpendicular height, and we've got, let me do it in green, this triangle. and we know its perpendicular height. Now it's provided with both that we call this vertical line the base of the triangle. The base of the red triangle and the base of the green triangle. We've got the perpendicular heights, we're able to calculate the areas of each of the triangles, add them together for the area of the total field, and we know that that entire base is this 67 because 67 tells us how far it is from C to A. So, becomes a nice simple exercise then in using the area of a triangle formula. So you can see the formula for the area of two triangles, half the base times the perpendicular height. So we've got half 67, and the perpendicular height of the red triangle is the 26. It's perpendicular to the base. And in the green triangle, the base is still 67, but the perpendicular height is this 22. And going to the calculator, you get 1,608. It said in part B, if walking from A to C, is it shorter to go via D or via B? I haven't got B in there. How much shorter to the nearest 0.1 of a metre? I'll pause the video and write that up and come back and talk about it. So you can see that I have redrawn the overall diagram and broken it into two sections. I've drawn here from A to C via D, and here I've got A to C via B. So this was the point B, which means this is a B and that's a B. And I think the top was the A and the bottom was the C. Same over here, except I've got the left-hand side. So A to C, and we're going via D. Now, if you're going via D, so we're going along here and then down there to get to C, I've actually redrawn those two triangles because the only way to get that length there is to separate this into a right angle triangle. And we know the other two sides were 26 because that was a perpendicular height, and we could work out that was 26 because it was the difference between 41 and 67. And now the way to get this now becomes a hypotenuse. So you're going to use Pythagoras' theorem. And normally we would have that P squared is 26 squared plus 26 squared, but we only want P, so I'm taking the square root of it. Same here to get Q, which would be this second leg of the path, and it's a hypotenuse again of a right angle triangle where the sides are 26 and 41. So instead of Q squared is 26 squared plus 41 squared, I only want Q, so I'm going to take the square root. Now you can see here I've done the first bit, square root of 26 squared plus 26 squared, and I will write that as, say, 36.8. Now, as you can see there, I've done that calculation and I've got that the total distance from via D, and I've just introduced this P and Q, ends up being, we'll say it's 85.3. And it said 0.1 of a metre, so that's very good. Meters to 1 dp. Now, I'm going to go ahead and do the same for the other side, going via B, and it's again just finding the hypotenuse of two right angle triangles. Now, actually what you can't see there, which has just come up as answer, is the square root 42 squared plus 22 squared. And to that then I've added the square root of 22 squared plus 25 squared. You can see that. And in total it is 80.7. So, what was the question? How much shorter? If walking from there, is it shorter to go via D or B? Therefore, it is shorter to go via B by the difference between 85.3. Oops. I think that was 4.6. Not much difference. Okay. I'll stop the video there and do the next two methods of surveying in a separate video.